DIY Glow Sticks, a study of chemiluminescence by Alice Al, Lucy Nyo, and Josephine Widjaja. Let's say you're in your house, braving a thunderstorm, and the power goes out. The lights turn off, and suddenly you're trapped in the dark. Luckily, you've conveniently got your complicated, expensive chemicals, all the right chemistry equipment, and the ability to conduct experiments in the dark. Perfect, now you're on your way to fulfilling this life hack by creating your own glow stick. Now, even if you're not entangled in the hopeless situation of a power outage, you can still conduct this life hack and craft your own glow stick. Glow sticks are thin cylindrical tubes that emit light after they're cracked. The first glow stick was invented in 1960 by Edwin A. Chandros. He created a light close to a firefly's glow, finding substances like the glowing active ingredient oxalyl chloride that could react with hydrogen peroxide. Today, diphenyl oxalates, or sialume, are usually the active ingredient. Glow sticks were ultimately popularized in the 80s, and they were also used by the American military as a light source. Glow sticks are essentially small glass tubes floating in a liquid inside an outer compartment. This compartment holds dye and the diphenyl oxalate, and the inner glass vial holds aqueous hydrogen peroxide. When the glow stick is bent, the inner compartment breaks. The peroxide reacts with the diphenyl oxalate. This breaks down the diphenyl oxalate into phenol in a molecule named 1,2-diazotadione, which is unstable and also breaks down, releasing energy and 2 molecules of carbon dioxide. Our experiment will replicate the chemiluminescence that causes glow sticks to glow. Chemiluminescence is essentially the production of light from a chemical reaction. Hydrogen peroxide accepts hydrogen ions from the luminol. The chemicals react and electrons become excited, jumping to higher valence levels. They release some of their energy as photons of light to reach their ground state.
Chemiluminescence is also used in forensics. A dilute luminol and hydrogen peroxide solution is often sprayed at crime scenes. If blood is present, the iron in the hemoglobin in the blood is a catalyst for the reaction, so the blood glows a bright blue. You can conduct your own chemiluminescence experiment with the following materials: 1 liter beaker, 1 300 milliliter beaker, 1 100 milliliter graduated cylinder, 0.1 grams of luminol, 1 teaspoon of red liquid from meat packaging, half a liter of distilled water, 60 milliliters of hydrogen peroxide, half a gram of ammonium carbonate, 0.2 grams of copper sulfate pentahydrate, 2 grams of sodium carbonate, 0.2 grams of cobalt 2 nitrate, 12 grams of sodium bicarbonate, a timer, a thermometer, 6 weigh boats, and a lux meter. The red liquid from meat packaging is optional, but it acts like a catalyst to the reaction. The red liquid is a mixture of water and myoglobin, a protein similar to hemoglobin. Remember to use goggles, aprons, and gloves to safely handle chemicals. Wash hands before and after the experiment. Wear long sleeves and make sure your bare skin does not contact any dangerous chemicals. These chemicals all have respiratory risks, so do not inhale them. At the end of your experiment, clean up by pouring all the mixtures down the drain and wash all your glassware with proper glass cleaning soap. Don't forget to dispose all weigh boats and gloves in the trash can. Pour 60 milliliters of hydrogen peroxide into the graduated cylinder. Pour 2 grams of sodium carbonate, 12 grams of sodium bicarbonate, 0.1 gram of luminol, 1/5 gram of copper sulfur pentahydrate, 1/4 gram of ammonium carbonate, and a half liter of water together in 1 beaker. Add luminol. Pour the hydrogen peroxide and the 1 teaspoon of red liquid and start the timer. Record the amount of time that elapses before the tube stops glowing. Use the lux meter to determine the brightness of the solution at its brightest point.
The DIY glow stick can be expressed with this chemical equation. In this equation, luminol is activated with an oxidant, hydrogen peroxide. Hydroxide ions in the water cause luminol, a chemiluminescent solid, to decompose into water and a dianion. Catalysts like the iron in blood make hydrogen peroxide decompose, producing water and oxygen at a lower activation energy. The oxygen then reacts with the dianion, forming an excited, unstable triple dianion while releasing nitrogen gas. This dianion later stabilizes, releasing energy in the form of visible light. Electrons fall from high energy levels to the ground state configuration. These equations are exergonic and exothermic, releasing energy. However, light, not heat, is released. The change in color and release of light indicates that the process is a chemical reaction. Substances like the sodium bicarbonate and the sodium carbonate increase the alkalinity of the mixture, allowing the luminol to dissolve more easily in a mixture with an optimal pH of 9 or 10. We made luminol glow sticks 4 times. For the first trial, we only made 5 tablespoons of the glow stick without the sodium bicarbonate. However, without the sodium bicarbonate to make the mixture more alkaline, the luminol couldn't dissolve. When we poured the mixture into the sodium hydroxide, not much of the luminol was added, so the glow stick only glowed at 3.1 lux. This only lasted for 3.5 seconds. For the second trial, we made 600 milliliters into a bowl without animal blood. The sodium bicarbonate helped dissolve the luminol better, and the mixture glowed brighter at 3.4 lux for 10.3 seconds. For the third trial, we poured 75 milliliters of hydrogen peroxide into the beaker, and this caused the mixture to glow brighter at 8.1 lux instead of 3. This lasted for 15.5 seconds. The animal blood we added also illuminated the mixture. Our last trial was exactly the same as the third one, but we only used 60 milliliters of hydrogen peroxide. However, we poured it in slower, and the mixture glowed at 8.3 lux for a total of 20.3 seconds. For each of the trials, the temperature stayed mostly consistent as the reaction releases energy in the form of light, not heat. In comparison, the lux of the school fluorescent lights are about 14.1 lux. Also, most luminol solutions for blood detection made by experts only last 30 seconds near our experimental value of 8 lux. So remember, if you are ever in need of a nightlight or glow stick, you can make your own temporary one with luminol and hydrogen peroxide. And if you have chemicals like TCPO or CPPO, you can actually use chemiluminescence to make glow sticks of different colors that can last for several hours. You can conduct your own experiments to explore the world of chemiluminescence and all its practical uses.